Welcome to today's Roads to Research presentation. Mickey Noble will be presenting today as our guest speaker, and she'll be presenting Mad Scientists, to self-as scientists, grade 1 students' perspective of scientists. And please be aware that this session is being recorded. And if you have any questions, there'll be about 10 minutes at the end of the presentation. So Mickey.
Okay. All right, thank you everybody for coming. As Gwen said, we're going to be talking about grade 1's perceptions of scientists, and we're going to start with a bit of an overview. So we're going to talk a little bit about our Royal Roads University Science Outreach Program. We're going to talk about a related project that was the Dr. Blasto project that actually looks at grade 1's perceptions of what a villain might be and how that kind of evolved into our project around scientists. So we'll talk about that for a bit, and then we'll present the research questions, background methods, and some concluding remarks. And as we go, you'll see lots of pictures as we go through that were drawn by the kids at various points through our project. This project is a collaboration between myself and another person at UVic, Christine Tippett. So you'll see Chris's name at various points in this, and this is my partner in crime from UVic. Chris brings her experience as a classroom teacher for elementary school students to the project and was kind of instrumental in helping us kind of both analyze the data and kind of write ethics forms for grade 1s, which is a bit of an interesting experience when you have to get informed consent from somebody who's 6. So just to start off, our Rural Roads Outreach Science Program began in 2004 with Brentwood Elementary, and we started off with one class of kindergartens. Our program currently involves students in kindergarten to grade 7, and we are corrupting these students one class at a time. And over the last year since we started this program, we've had over 1,000 students through our program. Some of them I've seen every year since they were in kindergarten, and others see us sort of for the first time at various points as they move into the district. The picture that's on the screen is part of our kindergarten group, and you'll notice their little lab coats because they need to feel like scientists. And the big question at the end of the day is usually whether they can have the lab coats or not. There we go. So originally our Dr. Blasto project was part of a session that we were doing with grade 1s. And what it really involved was a laboratory-based problem-solving exercise where the kids would go from station to station. And they were trying to figure out what Dr. Blasto had used to poison the ice cream, which is a big problem when you're 5. So they would go to the station, they would look at plates, and they would get clues, and they would look at microscopes, and they'd get other clues, and then we bring everybody together at the end to figure out what's happened to the ice cream. And the big question is usually, who is Dr. Blasto? And what was really interesting about this is we had intentionally written the story so that the villain was only ever referred to as the arch-villain Dr. Blasto. We never said Dr. Blasto was male, female, what color hair Dr. Blasto had, or anything like that. And so when they got back to school, one of the things that they would usually do is they would actually draw me a picture of Dr. Blasto. Now, if you ask somebody in our age group what a villain looks like, you'll usually get something that looks like this. Okay, kind of the classic lady on the train tracks kind of villain with the dark hair and the mustache and the whole 9 yards. But the question we were going to ask with this first pilot project was, what characteristics do grade 1s think villains have? And how do grade 1 students perceive a villain that doesn't have any gender in the story? And what prior knowledge do they bring to the table that is kind of coloring what they think a villain is? And then do the attributes that they ascribe to doctors influence the gender perception of what Dr. Blasto might be? Now, that last one kind of got added after some consultation with our faculty supervisors up at UVic, because although Chris and I considered that doctor was pretty gender neutral, and we figured pretty much everybody knew that doctors could be boys or could be girls, it was pointed out to us that that might not actually be the case, and we should probably ask the question, so we added that one on. So initially, all the students from the class came to the lab, they participated in the field trip. We made a mess, we made multicolored volcanoes, we made yogurt, and we did this as part of their activities. And generally, we did a whole lot of stuff that resulted in the perception, at least on the part of the grade 1s, that I must be some kind of a rock star because I make multicolored volcanoes, which is something that their teachers couldn't do. So they came afterwards. the teacher, as one of the follow-up activities, asked them to draw a picture of Dr. Blasto. Now, we kind of started off with this really generic set of directions, which was just draw a picture of Dr. Blasto. Unfortunately, there were a few kind of parameters that we didn't kind of think about, and one of them was the teacher interpreting the directions that they should just draw the character, that there should be no background, which is a little bit different than what we'd kind of intended. And the other was that this classroom has a 5 crayon rule for drawing, which means that you're not allowed to have your picture be black or red or green. You have to use 5 different colors in your picture. So that also resulted in a little bit more colorful pictures than we might otherwise have wound up with. After they drew their picture, we sent home consent forms. And writing consent forms for people who are 5 is really interesting because you need one consent form for mom and dad, and you need one consent form that the 5-year-old understands. And so you wind up with introductions on your forms that say things like, this is my friend Christine. Christine and I want to talk to you about villains, you know, and if you don't want to participate, it won't hurt our feelings. Which, I mean, sounds really, really silly when you're dealing with adults, but it's pretty important when you're 5. So out of 19 students that came to visit, we had 6 boys and 2 girls that were interviewed. And we asked them to just come and talk to us. And we asked them about, you know, what do you think a hero is? And what do you think a villain does? And what villains and heroes do you know about? And whether doctors and, you know, could a doctor be a boy or a girl, or a nurse be a boy or a girl? And we used a checklist for scoring their drawings after we had interviewed them, because we were looking for kind of commonalities. And seeing as we didn't have a lot of experience in generating or scoring drawings, we modified a protocol called the Draw Scientist Checklist, which I'm going to talk a little bit more about in the context of the other program. So when we did our scoring, we were looking for things like whether or not the Dr. Blasto was wearing a lab coat or a cape or clothing, what color it was. Eyeglasses, extra eyes was not something we anticipated, but we did end up having to score. Facial hair, wild hairdo, hair color, facial expressions, whether they had weapons or tools, whether they were male or female, and what influences we were dealing with in terms of cartoons that they might be watching on TV. So this is one of our pictures of Dr. Blasto that we got, and you'll note that we have a considerable number of extra eyes and a cape, which were actually pretty important as far as that child was concerned for their villain. Well, when we did the interviews, it turned out that as far as the kids were concerned, heroes and villains could be both boys or girls, although we did determine that girls could not be evil. This was what we were told by one of the little girls. We asked them if girls were usually villains, and she said no, because girls couldn't possibly be evil. And she left the room, and Chris and I went, oh, kid, you have no idea. But, you know, there you go. The kids were totally aware of the fact that both boys and girls could be doctors and nurses, and in fact, the only respondent we had that gave us any answer different than that was one of the little boys who was pretty sure that doctors were usually girls, but that was because his mom was one. So, you know, he had a slightly different perspective. So our most common features for Dr. Blasto ended up being extra eyes, a great big smile. In general, our villains were perceived very favorably, which was a little strange, but there you go. We had lots of capes. Our villains were generally male, in spite of the fact that they were pretty sure that boys and girls could both be villains. But we did see a really strong influence for popular media. So if we asked the kids what heroes that they knew of, we got, you know, DC comic or Marvel superheroes, because that's the cartoons that are on TV. So, you know, you got Batman listed and Superman, and there's not a lot of female superheroes in there. So we had a mention of Wonder Woman as a female hero, and Catwoman as a villain. But you didn't get a whole lot of those other things. Where most people in our age group would have had your villain having facial hair, like our sort of Dudley Do-Right villain that we had at the beginning there, the kids don't really perceive it that way for heroes or villains. And if you look at the cartoons that they look at, the villains and the heroes that they mention, of the entire suite of all of the ones that we got told about, there was only one character in that whole list that had any facial hair at all, and that's Green Arrow. And he was a character that's on the DC cartoons that are on right now. So facial hair seems to be a characteristic that's very much attributed to what kind of TV that they're watching. What we did find had a bit of an influence is we got a fair number of pictures like this. This was one drawn by one of the boys, and you'll notice the red blaster in Dr. Blasto's hand here, right? And this particular character also has rocket shoes. Okay, so just so we're clear on this, and we have a snazzy blue cape here. When we asked the kids why they thought Dr. Blasto was a male, we realized that we had unintentionally introduced a gender bias because Dr. Blasto sounds like blaster, blasters are a gun, and boys have guns. And apparently girls don't have guns, at least not according to the under 6 set. So we discovered we may have kind of introduced a bit of a gender bias there for Dr. Blasto. And it kind of left us asking the question, is a bad guy necessarily a male? And although we found this project to be interesting, and that was great, we had no budget for this particular project. It was a side of the desk project for both of us because we're both doctoral students engaged in other areas of research. And although there was a really nice literature gap here for us to fill, it was the size of the Grand Canyon, and it wasn't really meant to become our dissertation project. So seeing as we were both science people and we were really more interested in that aspect of it, we decided to go on and ask the question then, what do grade 1s think scientists are? So just to kind of wrap things up, in our Dr. Blasto project, we asked grade 1 students what a villain of a science mystery looked like. Interestingly, lab coats didn't show up at all in any of the pictures. They obviously perceived that the concept of them as a villain was more important than them being kind of the super villain scientist guy. It's sort of interesting. All of our participants depicted the villain as male despite the lack of gender cues in the story, and we have a villain that has a very, very positive perception because they are almost all smiley, and they have a big cape and extra eyes. And we think the extra eyes and the cape has more to do with villains being different from them, right? I'm not a villain, therefore the villain shouldn't look like me kind of perspective from grade 1s rather than necessarily having anything else to do with it. You have lots of not really. It is quite inventive. There are some characters, for instance, on Sesame Street that are monsters, but they generally only have 2 eyes. So like, you know, Elmo and Cookie Monster and those guys are still very popular with kids this age. And
sorry to interrupt.
yeah, and so basically we shifted our focus from villains to scientists. So our research questions for this one are, what characteristics do grade 1 students attribute to scientists, and how does a laboratory experience influence grade 1's perceptions of what a scientist might be? And here's our sort of stereotypical image of a scientist. This is Dr. Frink from The Simpsons. So just for some background so you can see where our methodology came from. In 1957, Mead and Mitro actually interviewed 35,000 American high school students and asked them to write an essay about what a scientist was. And this is actually kind of the seminal work in this area, and it generated a list of characteristics that are considered the stereotypical things that we think of a scientist as being. So if we were to ask everybody in this room, what does a scientist look like, I would get probably most of the things off Mead and Mitro's list. I would get the lab coat, and I would probably get the glasses, and you know, you get like a geeky looking guy like the cartoon character that I just showed you. And this kind of gives you the classic white middle-aged male in a lab coat and glasses, usually doing something dangerous in a lab, usually by himself, and threatening to blow himself up at some point. In 1983, Chambers developed the Draw Scientist test, and the idea was that this would provide access to kids that were younger and maybe not as good at writing essays and that kind of stuff at this point. And it actually developed from work by a person called Goodenough, and Goodenough's work was actually a draw man test. So the idea was, you know, what characteristics do kids attribute to being male? Chambers actually administered this to 4,800 kindergarten to grade 5 students and got a very similar set of stereotypical characteristics as Mead and Mitro did. And so that was considered to be a bit of a justification for moving on from there. And then the Draw Scientist checklist was created by Finnison, Beaver, and Cramen using that list so that you could actually score and do statistics on the various pieces of this. Now, all of the work that's kind of been done in this area is interesting because it's almost all done with students that are at least in grade 5. And I think there's kind of two reasons for that. One is that kids in grade 5 generally draw pretty well in comparison to their younger compatriots. And they are more likely to sort of have that established stereotype of what a scientist might be. And so most of the work that's been done with this has been done with older kids, lots of work with pre-service teachers, lots of work with high school students. And most of the studies on sort of those older kids suggest that while girls are more likely than boys to draw female scientists, male scientists are drawn predominantly by both genders, which is kind of interesting. Now, we thought that this would be kind of a better tool to use to be able to look at our stuff with the Science Outreach program, because it would be an interesting thing to look at this much younger group that's probably more in the process of developing their ideas about what a scientist might be. So our current study is a mixed method study. It's an observational case study, and we have student drawings, and we've scored them using the Draw Scientist test. We have interviewed kids, and so we've got semi-structured responses from the kids, and we have some anecdotes from the teachers that were sort of added into the mix here. So our participants were 19 grade 1 students from 2 classes. Our villain has now been renamed Erlenmeyer, and so those that have done lab work will find that funny, and the rest of you are going to go, what? An Erlenmeyer flask is a flask that's commonly used in lab work, and so we separated it and made it into a name. We were trying to be really careful about picking our name this time around because we were looking to not have that bias problem that we had with Dr. Blasto, but we were also trying to take into account with the number of cartoons and multimedia things. If you pick something that sounds too much like a villain or a character that they're familiar with, that's the drawing you're going to get. So you can't, for instance, pick Dr. Jones because that's Indiana Jones and you'll get nothing but pictures of guys with whips, and that's not going to do very much good. So we had 19 students from the 2 classes that returned the ethics forms and agreed to be interviewed. The gender distribution for our participant group mirrored what we saw in the 2 classes. And what we actually had them do initially was come for the field trip, and then before they came for the field trip, they drew a picture of a scientist. They came for the field trip, then we had them draw a picture of a scientist again, and then about 4 days after the field trip, I went into the classroom to do some follow-up stuff with them, and then after I had been, we had them draw a scientist for a 3rd time. So we're actually looking at kind of a time series of the kids' drawings over time. So this is just to show you that our participant group and our classroom groups are pretty similar, okay? About 40% of our study population was boys and about 60% was girls, and that's pretty much in line with what the 2 classes had if you add everybody up. Okay. Now, it's probably important to note here, we only interviewed the kids once, and we interviewed them after all 3 drawings had been done. There's sort of pros and cons with doing that, because if you interview the kids too many times, they start to get confused about what it is that they're doing and sort of start telling you what you want to hear instead of what they think. So we opted for only having the 1 interview session. Now, we also found out, we're really glad that we had decided to interview, because our participants had a wide range of developmentally appropriate drawing abilities that ranged from this. Okay, you'll notice that we have our very nice scientist, male scientist here, right, who is ready to go off and do his experiment, to this, to this. All of these are totally appropriate for the age group that they are. The kids are very much at a really wide span of their ability to express themselves in drawings. And so in a lot of cases, we actually got a lot more information when we were talking to them with their drawings so that they could tell us about the pictures rather than just looking at the drawings. Because as you can imagine, our first drawing that's primarily a stick man would have been a little difficult to score without some additional information. We also discovered that the details in the drawings were not always obvious. So this is a very nice, colorful drawing. And part of the interview for this one went like this. I said, what is your scientist wearing here? And Patty says, a tutu. And I looked at Chris, and Chris looked at me, and then we decided that maybe we needed some more information on those details. So Chris said, what do scientists normally wear? And Patty said, pants. And Chris says, pants? So why is your scientist wearing a tutu? Because it was dress-up day. So sometimes you get responses when you were dealing with this age group that would not have made any sense. The colors that are around Patty's scientist are not explosions, they're sparkles. Okay, because she thought they were pretty, not because they necessarily had anything to do with her scientist. So as you might imagine, we had this collection of drawings, and we had the master draw scientist checklist that was generated, and there were all kinds of characteristics on it, and we discovered that we could score gender fairly easily, whether the character was wearing a lab coat or not. Usually a lab coat was evidenced by pockets and buttons down the front of whatever they were wearing. Whether the character was wearing glasses, if they showed any equipment, some kids did, some kids didn't, and if it was obvious whether the character was inside or outside. Some of the kids drew Dr. Blasto, drew their scientist doing various things. Some of them gave us just the scientist, some of them had other things with them. In general, we found that you could not score age, okay, which is one of the things that was the characteristics that Mead and Metro had come up with. You cannot score ethnicity because you're limited by what color crayons you have. And if you have pink skin and you are drawing a pink scientist on pink paper, that doesn't work very well, so you generally get a black outline. We didn't see a lot of evidence of things like light bulbs or mythic stereotypes or indications that you were working in a secret lab or anything like that. Not in the drawings anyway. So this is one of our drawings. This is by one of the boys. And you'll notice the buttons on the lab coat, and you'll notice the lab coat is multiple colors. And the first time we looked at this, we couldn't, Chris looked at them first, and she says, you know, I don't know why we have this Technicolor lab coat in this particular picture. And then I pointed out to Chris, after I saw it, that my lab coat looks like this. I have a tie-dyed lab coat that is orange and green and yellow, and I generally wear it when the kids come. So this particular student drew his scientist wearing my lab coat. And it made for some sort of interesting kind of analysis when we started looking through here. So one of the things that was kind of a major interesting thing that we found is that girls were drawing girls and boys were drawing boys in far more prevalent numbers than what we would expect based on the stuff that you see with the older kids. So we'll talk some more about that in a second. We had some results around scientist to self or other that we thought were really interesting, and a lot of interesting comments on what the actual purpose of lab coats is, at least as far as the kids were concerned. So, first question, what is a scientist? Well, if we take all their responses and we do a Wordle, we get this kind of result. And when you first look at it, you think, okay, the hugest word here is stuff, meaning that's the word that came up the most. And you look at it and you think, well, that's not really very useful. And then you realize that it has a lot to do with the way that 6-year-olds express themselves. So if you ask a 6-year-old, what does a scientist do? They make stuff. They do stuff in experiments. They mix stuff. They do potion stuff. And it's not that it's not a useful word. It's that they don't have vocabulary to necessarily clearly articulate beyond stuff. But if we take stuff out, and we do the same thing, we get something that's a little more reflective of what scientists might actually do, at least lab scientists. So we still have potions because potions and solutions are kind of interchangeable at this age. So scientists mix stuff and they do interesting things and they do figures and they find stuff and they cure stuff and they look at things and they explode stuff and do experiments and all this kind of thing. So it is actually a useful exercise to have stuff in there, but then realize that if you pull it out, you get that kind of broader picture of what they actually think a scientist is and does. Now, if we go back to our boys drawing boys and girls drawing girls for just a second here, each of the children had 3 drawings. Okay, so they had the before they ever came for the field trip, when the teachers mentioned that there were some of them that didn't actually know what a scientist was. Their first drawings are in some cases not very reflective of their later ones. They had their second drawing after they'd been for the field trip, and the third drawing after I had actually been to class. And if we look at the sort of the set of 3 drawings, we find that boys are mostly drawing boy scientists and girls are mostly drawing girl scientists, although there is some cross-communication in terms of a few boys drew girls as their scientists and a few the girls drew boys. And again, if we just put this up like this is way, way different than what you see with older kids. With older kids, you will see even the girls are primarily drawing the boys as their scientist as being a male. And it's maintained pretty much all the way through. So in their initial drawings, they're mostly drawing the same gender as themselves. Right after the field trip, there isn't any crossover. And then after probably about 4 days later, you still get that kind of that return bump where they're drawing the other gender, but they're still primarily drawing their scientist as being their own gender. And that kind of led directly into a few questions that we had afterwards. So this is a drawing by one of the girls. This is Erin's scientist, and you can see in this drawing it's pretty apparent with the long hair that the scientist is actually female. But in this case, we start to see some of the labeling, and some of the kids are starting to label their second drawing, and it's them as the scientist. So we wound up with a lot of conversations that went like this: most of your scientists are girls. And Kate says, yes, that's because it's me. And I said, so you could be a scientist? Yep. And in fact, if we look at how many of them identified the scientist in their drawings as being themselves, the girls are drawing, of 8 participants, nearly half of them drew themselves more than once as the scientist after they'd been for the field trip and they'd had that hands-on experience. The boys didn't do that as much, which was interesting, but you did still get the boys identifying with that. There we go. So one of the questions we asked is, what do scientists wear? So this is one of the boys. A lab coat. And Chris said to him, why? Why do they wear lab coats? Because they don't want to get anything on their clothes. So we asked one of the girls, what do scientists wear? Lab coats. Why do they wear lab coats? So they don't get dirty. What's your scientist wearing? A lab coat. Why would she be wearing a lab coat? There's something spilled over. So we come to the startling conclusion that at least when you're dealing with grade 1s, a lab coat is not a symbol of science. It has a purely pragmatic function that it is to prevent you from getting stuff on your clothes. In the same way that you would wear a smock if you were painting, if you're doing messy science, you wear a lab coat. That's really interesting because by the time kids are in grade 5, a lab coat is a symbol of science. And it doesn't matter what kind of science you're talking about, they figure that the scientist should be wearing a lab coat. So again, this makes things very, very different than what we've seen previously in the literature. So as sort of an extension from that, we did ask about eyeglasses, because again, that's something that you see a lot with older kids. And again, we have that same very pragmatic piece to it. We only had one set of drawings that had eyeglasses in it, and it was one of the little boys, and he had drawn himself as a scientist, and therefore the scientist had eyeglasses on. But as far as the other kids were concerned, eyeglasses, again, were not a symbol of science. They had the purely pragmatic function that you needed them to see. So that would be why a scientist wore eyeglasses, not because of any other reason. So this kind of brings us back around to our question that we started with, which is, what exactly is a scientist and what do grade 1s think they are? And one of the things that kind of emerges from the study that we've done and the work we've done in this area is that we are dealing with an age group that is very much in the process of forming their concept of what a scientist is. And it's really, really easy at this age to alter their concept. So if they come in and they have that hands-on experience in the lab, that tells them that science is not something that's done far away and by people that are special. It's done by people like them. And so you start to see that reflected in their drawings, where about half the kids are drawing themselves as scientists in their second. It also kind of brings up the point you have to kind of look fairly carefully at the curriculum for this age group, because the concept that we'll just ignore the science stereotype until they get older and they can understand. By the time they're in grade 5, that middle-aged balding guy with the glasses and the lab coat has become their concept of what science is. And it starts to turn off kids because that's not me. Right? That individual doesn't look like me. Why would I do something like that, right? So again, just to emphasize, the students were really clear that both boys and girls could be scientists. They were really seeing themselves as being that active participant in doing science. And so I think what this comes down to is that we need to capitalize on that science as self piece very early on. And we need to not be afraid of using characters like Miss Frizzle from the Magic School Bus that look like they could be fun, that look like they could be entryways into having kids become interested in science. Okay, and again, purpose of lab coats, not a stereotypical negative kind of stereotype. At this age, it is a purely pragmatic, you don't want to get messy when you're doing stuff. And so, their conception of Dr. Honeydew and Beaker from the Muppets is not that these guys are wearing the lab coats because because they are scientists. They're wearing the lab coats because of what they do. So rather than avoiding quirky or mad scientist characters, I think primary teachers can very much take advantage of that. They can use them as an interest hook to get kids interested and involved in science, and take the opportunity to talk about some of these characteristics that we think are associated with scientists. In addition, I think it's really important for teachers to actually implement hands-on stuff in the classroom so that the kids can actually see themselves as scientists. And that's probably one of the greatest pieces of our science outreach program here at Royal Roads, is we have the ability to bring classes in to do stuff that is too loud, too messy, can't be done with carpet, that you need different expertise for, that is too dangerous to do at school in ways that you really can't manage. So when we have the grade 5s in, we blow up gummy bears. When we have the kindergartens in, we blow up Coke and Mentos and we make a huge mess out the back of the lab. That's not a problem because we're not dealing with it in that sort of school situation. So, references for those who need. Otherwise, questions? Yeah.
Did you notice if any of the children's impressions as they were drawing it influenced anybody else around them?
It really didn't seem to, because they were doing it as an individual exercise. At least the way that particular grade 1 system classroom is set up. It's set up as tables, and everybody's kind of got their own side of the four-sided table, and so they can all kind of do their own thing independently. And it's meant to be that way to help them concentrate with their writing, because at that age it's a lot like herding cats, right? So I mean, any distraction winds up being a major issue usually at that stage in the game. Yeah.
How would you change the curriculum between grade 1 and 5 in order to...
For our outreach program?
Mm-hmm.
The grade 1s do things that are more...
No, but how would you change the BC curriculum?
The BC curriculum. The BC curriculum is really difficult to deal with because it's constrained. The learning outcomes are quite open-ended. Right? They say things like, children will have a knowledge of, and it's a really broad area. Some teachers are a lot more comfortable with science stuff than others, but they are all constrained by the fact that most of these rooms have carpet, which means you cannot do things that are going to overflow onto the floor. So for instance, one of the things that we do with the grade 1s when we bring them up here is we do multicolored volcanoes, which really is baking soda and vinegar and a squirt of dish soap so it hangs onto the foam, and some food coloring. And we can do that in a big tub and a 1-liter beaker and have enough foam to fill the tub. And if it flows over onto the floor, it's not a huge problem. But they think it's really, really exciting, right? You can't do that in a room with carpet, because if you overflow it onto the carpet, you're dealing with cleanup issues that, you know, probably can't be managed very quickly. So we have that kind of piece to it. That said, I have seen some very, very creative elementary school teachers that have managed to bring a tremendous amount of hands-on science into their classroom, even with those constraints. But some of them really didn't have that exposure to science in that way themselves when they were undergoing their training, and so they really haven't had a chance to kind of switch gears to allow that stuff to happen more. Yeah.
Any recommendations been made to school boards or PC curriculum regarding the results of this?
Because we needed an ethical review from Saanich School District, Saanich School District also has our results. So we hope that they will be interested in discussing them with us some more.
Just to add on to it, I work for Mad Science, and they actually do after-school programs too with lots of the kids that sign up. So that's also another way to get involved, and the kids love it. It's just, yeah, and they want to be there. That's another thing that's really cool about it, because they sign up and they want to actually come after school and do it after school hours.
Yeah, Mad Science tends to be older kids. What I found is really interesting, is particularly about dealing with the younger elementary school students, is I inevitably have had parents say, well, what if my child's not interested? I've been doing this since 2004. I had never yet had a kid arrive at the lab that wasn't interested in being there and wasn't hooked within about 3.5 seconds of us starting. So I think a lot of are you interested in it really comes from, did I ever get exposed to it at an age when I was maybe a little bit more open to the idea that this was something I could do or I could be. Whereas by the time they're in grade 5, it's starting to look like the only science I'm going to do is reading the science textbook. Then you start getting into problems where kids think science isn't interesting without realizing that science is a really, really big field.
Did you have any discussions with the kids about other types of scientists? I mean, you've hinted it in your presentation, but, you know, sort of field scientists and...
Yeah, their experience day up here involves inside and outside stuff. So there's a field science component to what they do when they come up, not just with the grade 1s, but with the older kids. For instance, John has been kind enough to come and talk about owls with the grade 5s and his owl research. Alison Moran has been kind enough to come and talk about her hummingbird research with the grade 3s. So we're trying to give them that sort of broader based experience so that they understand that not all scientists do the same things, and some scientists spend more of their time in rubber boots and jeans outside in the mud than they do in a white lab coat inside, right? And that different scientists do different things. You know, because how are you supposed to know that you want to be a marine biologist or a soil scientist if you never get the chance to find that out?
I found the graphic image when you demonstrated how they drew themselves after pick 1, 2, 3, the second 100%. They are identifying as their own gender, which I think is such a clear, and it goes way beyond science, that children that have the opportunity to do something then see themselves being able to do something. It's right, it's such a direct representation of, it's me, it's much more likely to be them in the picture, they've just done it, and they can do it. I think it's an incredibly powerful message that goes way beyond just this area that I hope will be put out there. I think it's an incredible piece, actually.
It's really interesting, because if you look at the results for older kids, even if you're dealing with grade 5s that are doing this for the first time in the literature, it's less than half the kids draw themselves. And in some cases, it's no more than about a quarter of the kids drawing themselves as themselves in that place. So I think that speaks to how important that early exposure becomes when they're formulating those ideas.
All options open, the possibilities of who they can be in all domains.
Yeah, we were actually laughing because the first year that we did this, the kindergarten teacher asks them, you know, what they want to be when they grow up at the end of the year, because it's part of their end of the year slideshow. And she was saying that was really interesting, because that was the very first time that she had ever seen scientists hit the list with ballerina and policemen and firemen and, you know, the odd monster. You know, 'cause there's still the odd, well, there's still the odd kindergarten student that, you know, is going to grow up and be a pirate or a monster, right? So, but she thought it was really interesting how much influence that experience had had.
Any plan to track these kids at all through the school system, see if their attitudes remain?
I think it would be interesting, and actually, because the group that's in grade 7 now, that will be coming this spring, some of the kids in that class have been to visit us every year since they were in kindergarten. I think once I get my own dissertation work out of the way, I think it would be an interesting longitudinal study to kind of pick classes that had that sort of that longer relationship and see if they are different from the kids.
How many of them actually become scientists?
Well, I think we're a ways away from that one yet, but yeah. But for instance, in that grade 7 class, I think there are 15 or 16 out of 28. Because you don't get a lot of movement in and out of this district, so it's mostly a case of how they get resorted when they get put into separate classes. There's probably 15 or 16 kids out of that 28 kids that have been to see us every year since they were in kindergarten, or
Where they're really
starting to have
knowing
some.
about stuff and thinking about what they might want to do for real.
Yeah.
Yeah.
So I think it would be interesting a couple of years from now, when that group hits Stellies, which is the high school in that district, to see what effect some of these experiences might have on some of the choices that they make for electives.
I wanted to come back to Isabel's point, because when we first spoke of this, I said, well, sure they draw female scientists because both you and your colleague are female scientists, and so they were being descriptive. But it's much more powerful when you realize they weren't drawing you at all. They were drawing themselves.
They were drawing them.
I find that is a very clear message of what you were saying.
Now, that's not to say that Chris and I didn't have some influence, because
Yeah.
we did get, for instance, some pictures that were their third picture, where the scientist was still them, but the scientist was wearing blue pants and a long-sleeved orange shirt. And it took us a little bit to realize that when I had gone to class that day, I was wearing jeans and a long-sleeved orange T-shirt. So yeah, apparently, it's actually quite funny to walk in that school right now, because most of the kids know who I am. And so if you've got parents that don't know anything about this yet, because they've just moved into the district, you know, they're like, you know, what's going on? Is this the new lab, the new learning assistant or something? You know, because all the kids are saying, hi, you know, are we going to come? Are we going to come? Right? And so it's our outreach program that kind of started as something very small has become very much integrated into the curriculum at this particular school. And so we've actually had a tremendous amount of influence, I think, on how science is taught at that particular school.
Just wondering, how long has that program been at Royal Roads? Have the kids come?
2004. I was running similar programs to that when I was working at UVic, because I'd been involved with Science Venture and some outreach programs with the local high schools.
You know that organization, Women in Science and Engineering?
Mm-hmm.
You should get them to fund something like this to go on for a long time. This is very powerful.
Thought of that. That would be it. I think we better get the dissertation done first. Any other questions? Any other questions or comments? All right, I would definitely like to thank everybody for turning up. It's always nice not to talk to the empty room. And if you have other questions or comments about it, please do feel free to drop me an email.